Let us review what alternate angles are. Assume we have two lines, line A and line B on one plane and another line C which intersects the two of them. Lines A and B may or may not be parallel. Line C is called the transversal, and 8 angles are formed when a transversal intersects two distinct lines, 4 of which are interior, angles 1, 2, 3 and 4. Angle 1 and angle 3 is one pair of alternate interior angles, and angle 2 and angle 4 is another pair of alternate interior angles. Here's the beauty of alternate interior angles. Even if one pair of alternate interior angles are equal, then lines A and B will surely be parallel. In this case, if angle 1 equals angle 3 or if angle 2 equals angle 4, then lines A and B would be parallel. Let's erase this and try to understand what the alternate angles test says. If a pair of alternate interior angles formed by a transversal of two coplanar lines is congruent, then the two lines are parallel. But we need to prove this, and the best way to prove anything in geometry is by representing it diagrammatically. We draw two coplanar lines and a transversal through them. Let one of the lines be line P. We can also call it line AB. This is line Q, which can be called line CD. And this is transversal R, called line EF. As we can see, the transversal R meets the lines at 2 points. Let's call them points G and H. The only reason why we named each line and each point is because angles are involved. We can now call this angle AGH. We can call this angle here GHD, and so on. So what exactly are we proving out here? Before we find out what we have to prove, let us note the things that are given to us. The first thing that we know is the fact that lines AB and CD are coplanar. And we have one pair of alternate angles congruent. Angle AGH is congruent to angle GHD. This is all that we have. And what do we have to prove? We have to prove that line P is parallel to line Q. By just looking at the figure, there's no obvious way to prove this. And as I've mentioned before, when there is no obvious way, we try indirect proof. With the given data, let us assume that lines P and Q intersect. So if we prove this assumption wrong, then we would be successful in proving that lines P and Q are parallel. How would the lines look if they intersected? Let's redraw the figure. We draw line P, which is line AB like this, and we don't change the direction of line Q, which is line CD. And the transversal R intersects line P and Q at points G and H respectively. This is how the figure would look like if the lines were not parallel. If the lines P and Q are extended, then they meet at point Z. They meet at point Z to form triangle GZH. Let me repeat what we aim to do here. We were given that angle AGH is congruent to angle GHD, and we had to prove that lines P and Q are parallel. So by using indirect proof, we make an assumption that lines P and Q intersect. And now our aim is to prove that this assumption is wrong. Because if lines P and Q intersecting is wrong, it means lines P and Q are parallel. Now look at the second figure closely. Focus on these two angles. Measure of angle AGH plus measure of angle ZGH will equal 180 degrees as these angles form a linear pair. Look at triangle GZH. The sum of all three angles of a triangle equals 180 degrees. Angle ZGH plus angle GHZ plus angle GZH will equal 180 degrees. Both these expressions equal 180 degrees. It means they are equal. Notice that angle ZGH is common to both the expressions, and so we can cancel it out. What we get is angle AGH equals angle GHZ plus angle GZH. Let's understand something very interesting now. If 7 is equal to 4 plus 3, we can surely say that 7 is greater than 4 and 7 is greater than 3. Basically, if one number is written as a sum of two positive numbers, then that number is definitely greater than each of the numbers. So in this case, we can say that angle AGH will be greater than angle GHZ. And angle GHZ can be written as angle GHD. So we get angle AGH to be greater than angle GHD. But the given statement says that these two angles are congruent. So our assumption contradicts the given statement. So our assumption turns out to be wrong. And if line P and Q intersecting is wrong, then line P has to be parallel to line Q.